All right, so as we talked about before, burning fossil fuels, which is a huge part of how we get our energy, the main focus of the whole burning process, the combustion process, is that energy. So the whole reason why we burn fuels, we burn coal and we burn petroleum oil and gasoline. We burn these things because we're after the energy that gets produced. That is the most important product of that reaction. So we're going to talk a little bit about that energy in some more specifics today. Okay. We have two situations that can occur, and at the top of your notes here we're going to kind of break these words apart. So the word endo means to enter. Notice en, endo, enter, they match. The prefix exo means to exit. So again, ex in exo and ex in exit, they match. So that can help you remember what endo and exo mean. Now, the piece of the word thermic means energy. So if we put this all together, what do you think the word endothermic and exothermic mean? You got it. Endothermic means energy is entering. To enter energy. Exothermic means energy is exiting. And when we talk about entering and exiting, we talk about that the energy is either entering the chemical reaction or energy is exiting the chemical reaction. Okay, chemical energy, just as a reminder, is the type of energy that's stored in the bonds of chemical compounds. Okay, so in order to hold two atoms together, it actually takes a little bit of energy. And that energy gets stored right in that bond that holds them together. Now, when we burn things, we break those bonds. And when we break those bonds, it releases that energy as heat or light. So when we have these energy flows, okay, we can have endothermic or exothermic. So again, endothermic means that energy is entering the reaction. So if you have a reaction in a beaker and the energy in the environment is actually going in to the reaction in the beaker, meaning it's pulling energy, if let's say your hand is on the outside, it's pulling energy away from your hand into the beaker, that means that it's going to feel cold. Exothermic reactions have energy exiting the reaction, meaning that energy is being given off. Okay? If the energy is being given off, it's going to go from the reaction into your hand. That's going to feel warm to you. Okay? So that's always a really good indicator if you're not sure if something's exothermic or endothermic. If you can feel the temperature difference, that can give it away. Okay, so reactions pretty much take place in two steps. First of all, bonds need to be broken. All right, so you have your reactants, and we want to take the atoms in those reactants and rearrange them. Well, in order to rearrange them, first you have to detach them from each other. So we break the bonds, holding them together, and when we break those bonds, that releases energy. So that first step in a reaction is exothermic. The next thing that happens is now that you've broken all of the atoms apart, you got to put them back together in a different order to create your new products. Well, when you're putting them together, you have to store energy or take energy in to store it in those bonds, so that process is endothermic. Now, whichever one is stronger is what the overall reaction will have. If that first step is stronger, the overall reaction will be exothermic. If the second step is stronger, then the whole process will be endothermic. Okay? When we write these, an exothermic reaction, because exo means energy is exiting, you'll see the energy is written as a product. It's on the right side of the arrow, because these are the things being given off by the reaction. Think of the arrow as the reaction, right? So this stuff is going into the reaction, and these things are coming out of the reaction. So if it's exothermic, it's giving off energy. It means energy is coming out of the reaction, so energy will be written as a product. In an endothermic reaction, energy is being taken in, or it enters. So again, if you think of the arrow as the reaction, this stuff is going into the reaction. So in an endothermic reaction, energy is written on the left side of the arrow as a reactant. Okay? So if you're given chemical equations based on where you see the energy written, that will tell you if it's exothermic or endothermic. Here's an example of burning methane. So we have methane here, CH4, plus oxygen. Here's where our chemical reaction takes place, and it produces CO2, water, and energy. Okay, notice our energy is written as one of the products. It's one of the things that's being given off here. So that means that burning methane is an exothermic reaction. And if you remember from your combustion notes earlier in this unit, all of our combustion reactions look like this, and they all have energy in the same place. So all of our combustion reactions are exothermic, which makes sense because when you burn things, you feel the heat. And remember that exothermic is going to feel warm to you. Okay, here's another example. Okay, the dissociation of water. So you take energy and you combine it with water. You have a reaction take place, and that splits that water up into hydrogen and oxygen. So in this case, is energy being put into the reaction, or is energy being given off by the reaction? In this case, the energy is on the reactant side, meaning it's being put into the reaction. It enters the reaction. So if it enters the reaction, that means that this is a endothermic reaction. And there you have it. If you have any questions, let me know.